It is the last week of a dig that was supposed to be over. June 2023, a quiet field near the village of Norton Disney in Lincolnshire, England. A team of volunteer archaeologists has spent an entire season pulling pottery shards and broken roof tile out of a Roman rubbish pit, the kind of unglamorous debris that makes up 90% of any excavation. Trench 4 was only open because there was time left on the calendar. Nobody expected Trench 4 to matter. Then a trowel hits something that is not soil and not stone. The digging slows down. Hands replace tools, and out of nearly 2,000 years of packed earth comes a hollow bronze object with 12 flat faces, a small metal ball fixed to every corner, and a circular hole punched through the center of each face, no two holes quite the same size. It is heavier than it looks, dense with old metal, and in a state of preservation that stops the whole group cold, because most objects like this come out of the ground cracked, corroded, or missing half their structure. This one comes out whole, complete, undamaged, as if it had been buried yesterday instead of some 1,700 years ago. Within days, word of the find spreads through British archaeology circles, and then past them into international headlines. Because this bronze object, cast somewhere in the later Roman Empire, is not a new discovery in the sense of being unfamiliar. Similar things have been coming out of European soil since the 1700s. Roughly 32 of them had already turned up across Britain before this one. The strange part is not that another had been found. The strange part is what has never been found alongside any of them in nearly 3 centuries of digging. An explanation. Not a single sentence in the entire surviving body of Latin and Greek literature refers to this object. Not one. No name for it. No manual describing what it does. No mosaic, no fresco, no tombstone carving showing a Roman citizen holding one and using it for its intended purpose. An empire that cataloged everything, from grain shipments to military latrine schedules, left behind a technically sophisticated bronze artifact, and apparently never wrote down what it was for. That silence is the real mystery here, and it is about to be tested by a piece of software nobody in the 18th century could have imagined. To understand why the Norton Disney find mattered so much, you have to go back to where this whole puzzle started. The first documented specimen of what we now call a Roman dodecahedron was reported in 1739, pulled from a field near Aston in Hertfordshire and brought to the attention of the Society of Antiquaries of London, a body of gentlemen scholars who had been meeting informally since 1707 and would not receive an official royal charter until 1751. Their verdict on the object, after examining it as thoroughly as 18th century scholarship allowed, amounted to a shrug, clearly Roman in origin, clearly made with skill and expense, completely unidentifiable in purpose. That verdict, delivered nearly 300 years ago, has essentially been repeated by every subsequent generation of archaeologists who has handled one of these objects since. The craftsmanship was never in question. The function always was. Since that first find, roughly 130 examples have surfaced across the territory of the old Roman Northwest, in England, France, Belgium, Germany, Switzerland, Austria, Luxembourg, the Netherlands, and Hungary. They range in size from about 4 centimeters up to 11 centimeters across, roughly the range between a golf ball and a fist, and their weight varies from as little as 35 grams up to specimens weighing over a kilogram, a spread that itself is strange for supposedly the same tool. The holes drilled through each of the 12 faces are not identical either. Across the corpus, hole diameters range from about 6 millimeters up to 40 millimeters, and critically, within any single object, no 2 holes match. They graduate from smallest to largest around the shape. And here's the detail that has haunted researchers for centuries. These objects appear constantly in the northern and western provinces of the empire, the militarized frontier zones along the Rhine, the Danube, and across Britain and Gaul, and they are almost completely absent from Italy, Greece, Egypt, and North Africa, which is to say absent from the oldest, wealthiest, most thoroughly Romanized, and most heavily excavated parts of the empire. If you dig in Pompeii, a city preserved almost perfectly under volcanic ash with an enormous amount of everyday Roman material intact, you essentially do not find these. If you dig along a cold, wet military frontier in Roman Britain or the Rhineland, you find them with some regularity. That is not a small clue. That is close to the whole case. Consider what the pattern rules out immediately. If this had been a religious or ceremonial object tied to any of the officially recognized Roman cults, you would expect it concentrated in the temple-dense heartland of Italy and Greece, where organized religious life was oldest and richest. It is not there. If it had been a common household tool, something every Roman family might own the way modern households own scissors, it should turn up everywhere Romans lived, rich province and poor province alike. It does not do that either. Instead, its distribution tracks almost exactly with the zones where Rome was actively pushing its borders outward, garrisoning new territory and building the infrastructure of conquest, roads, forts, and boundary lines in unfamiliar and often hostile ground. Whatever this object was for, its use was tied to the frontier itself, to the business of measuring and organizing land that had only just come under Roman control, rather than to settled civilian life in the empire's old core. None of that would matter much if these were cheap trinkets, but they were not. Each one was produced using lost wax casting, a method that, by its nature, destroys both the original wax model and the surrounding clay mold in the process of making a single object. A craftsman first sculpted a wax version of the dodecahedron by hand, carefully laying out 12 regular pentagons, so they folded into a closed solid without any gap or overlap. A task that requires real command of geometry that had already been formally described in Euclid's Elements around 300 BC, some 4 centuries before any of these Roman workshops were casting bronze. That wax model was packed in clay, and then the whole thing was heated until the wax melted and ran out, leaving a hollow mold in its exact shape. Molten bronze, an alloy of copper and tin, and in at least the Norton Disney example, a strikingly high proportion of lead, around 27%, was poured in. Once the metal cooled, the clay mold had to be broken to free the finished object, meaning no mold could ever be reused and no 2 dodecahedra were ever produced from a shared master pattern. Every single surviving specimen represents its own individually sculpted wax original, made from scratch by a craftsman working from geometric knowledge and, evidently, from a recipe of proportions that traveled with him. Good tin, one of the 2 essential ingredients for bronze, was not something every corner of the empire had in abundance either. Cornwall in southwestern Britain was among the most important tin-producing regions in the entire ancient world, worked by Mediterranean traders long before the Roman conquest. And it sits inside the very same northwestern zone where a disproportionate number of these dodecahedra keep turning up. That overlap between raw material and finished artifact is unlikely to be a coincidence. Given all that expense and effort, the fact that roughly 130 examples still survive today implies something important on its own, because bronze, in the ancient world, was a recyclable commodity. Objects that lost their usefulness were routinely melted back down into scrap and reforged into something else. Nobody in the ancient economy kept a purely decorative curiosity around for generations at that scale of surviving numbers. People buried these things carefully, sometimes packed away alongside hordes of coins, the way you hide something you fully intend to come back for later, not the way you discard clutter. Something about these objects was worth protecting. So what were they actually for? Over the centuries, a handful of theories have gathered enough serious support to be worth examining directly, and each one collapses under a different piece of the evidence. The oldest popular theory treats the dodecahedron as an elaborate candle holder, with the graduated holes meant to fit candles of different widths, and the little corner knobs acting as feet to keep it standing upright. It is a tidy idea, and a small amount of reported wax residue inside at least one specimen has occasionally been cited in its favor, though that finding has never been widely replicated, and residue inside bronze buried in acidic soil for 2 millennia is not the sturdiest evidence to build a theory on. The bigger problem is economic. A candle holder does not need precisely cut regular pentagonal faces, a calibrated sequence of hole diameters, or the services of a skilled bronze caster, when a simple clay socket does the exact same job at a fraction of the cost and effort, and a candle holder gives no reason at all for the object to vanish almost entirely from Italy, where people burned just as many candles as anywhere else in the empire. A newer and far more viral theory proposes these were knitting tools, specifically frames for producing the fingers of gloves with different holes corresponding to different finger widths. A modern demonstration showing that a dodecahedron actually can be used this way spread widely online, and that demonstration is genuinely persuasive on its own terms. But being usable for a task is not the same as being built for that task, and this is exactly the trap the theory falls into. Across roughly 130 surviving specimens, not one has ever shown fiber residue, a preserved fragment of ancient yarn, or the kind of wear pattern that repeated friction from wool would leave on soft bronze over years of use. There is also a mathematical problem. Human fingers vary continuously in width from person to person, so a true sizing tool should show continuous variation in hole diameter as well, tailored to individual hands. Instead, the holes across the corpus, stepped through fixed, repeating proportions, cast the same way in workshops hundreds of miles and years apart, which looks far less like a domestic craft tool and far more like an object built to a shared external standard. The religious or ritual explanation is the hardest of all to fully dismiss, precisely because it is so flexible. Under this theory, the dodecahedron is a devotional object, connected to Platonic philosophy's association of the dodecahedron shape with the structure of the cosmos itself, buried alongside valuables because it held sacred meaning to its owner. It is a theory that can absorb almost any inconvenient detail without being falsified, which is itself the core problem. An explanation that can never fail to explain anything is not really being tested by the evidence at all. When you press this theory on its specifics, it goes quiet. 12 carefully graduated openings of differing size are not a natural feature of a religious symbol. They read like a functioning mechanism. The Roman world's confirmed ritual and cult objects that survive from this era are overwhelmingly carved from stone or bone, humble materials suited to devotional purposes, not cast in expensive bronze, using a destructive one-shot casting method. And geographically, a supposedly Platonic sacred object should logically appear where Platonic philosophy was actually taught and practiced, in the Greek-speaking eastern half of the empire, and instead it clusters almost entirely on the militarized western and northern frontier while avoiding the philosophical heartland completely. The geography runs precisely backward for a religious reading. The idea that these were simply gaming pieces barely survives contact with the evidence. No board game whose Roman rules have come down to us, not ludus latrunculorum, not tabula, calls for anything resembling this shape, and no civilization commits this much metal, skilled labor, and casting precision to producing a single token for recreational play. A far more inventive theory, proposed by Dutch researcher Gerard Wegemans in 2014, suggested these were agricultural calendar tools used by sighting sunlight through the graduated holes to calculate ideal planting dates based on the angle of the sun. It is a clever idea that at least treats the varying hole sizes as functionally important rather than decorative, but it runs into the same geography problem as the religious theory. Grain farming happened everywhere across the Roman world, including throughout the Mediterranean heartland, where these objects are conspicuously missing. A farmer's seasonal calendar tool should show up in the fields of Sicily and the Nile Delta just as readily as along the Rhine. It simply does not. Every one of these explanations shares the same underlying flaw. Each one solves part of the puzzle while breaking on another part entirely, whether it is the shape, the calibrated holes, the cost of production, or above all the stubborn geography of where these objects do and do not appear. And meanwhile, one group of Roman professionals whose documented job matches almost every constraint of the puzzle has been sitting in plain sight in the historical record the entire time, just never explicitly connected to this object. Roman land surveyors, known as agrimensores, were the technicians responsible for turning newly conquered, unmapped, often hostile territory into precisely measured grids, boundaries, and building plots, frequently working at speed, in unfamiliar terrain, with a military unit waiting on their results. Their profession is documented in a surviving body of technical writing known as the Corpus Agrimensorum, and their known tools included the groma, a cross-shaped sighting instrument using plumb lines to establish straight lines and right angles, the chorobates, a leveling instrument described by the architect Vitruvius and used for calculating the extremely shallow, precise gradients needed for aqueducts, and the decampita, a standardized 10-foot measuring rod. Surviving Roman technical literature on surveying is patchy at best, and it would be naive to assume these three instruments were the only tools such technicians carried into the field. The theory that has gained the most traction among researchers, taking this object seriously as engineering rather than decoration, proposes that the dodecahedron functioned as a rangefinding or calibration device used to estimate distance or angle in the field. The underlying principle is straightforward trigonometry, well within Roman mathematical capability. If you know the true size of a distant reference object, and you measure its apparent angular size in your field of view, you can calculate the distance to it, held at arm's length and sighted through the graduated holes toward a landmark of known height. Whichever hole exactly framed that landmark would give a distance reading calibrated directly into the instrument itself. This reading is the only one that treats the varying hole sizes as functionally essential rather than incidental, and it fits both the expense of the object and its frontier-heavy geography precisely. A Roman legion establishing a new camp, cutting a new road, or bridging a new river needed fast, repeatable, and above all consistent measurement. Consistent enough that a surveyor working one stretch of road could hand off to a colleague working the next stretch in a different province, with both arriving at compatible numbers. That kind of consistency demands more than individual skill. It demands a shared, portable standard. The honest objection to this theory has always been fair. No surviving Roman text names an instrument matching this description. No surviving Roman artwork depicts a surveyor holding one the way Roman art clearly depicts a surveyor holding a groma, and no dodecahedron has ever been recovered with any kind of mounting fixture, which would have helped stabilize it for precise sighting. The theory is plausible. It has never been proven. What finally moved this argument from plausible speculation towards something closer to demonstrated pattern was not a new excavation, but a new way of interrogating the numbers already sitting in museum records. Researchers had long measured the hole diameters on individual specimens, and physicists working independently, including researchers at Italy's Politecnico di Torino, had already begun treating these objects mathematically rather than purely as archaeological curiosities. The more recent step went further. Detailed measurements from specimen after specimen, stripped of all archaeological labeling and cultural context, were run through Grok AI as pure numerical data, with a single question posed to the analysis. Is there a consistent mathematical relationship among the 12 hole diameters on any given object? And does that relationship reappear across different specimens that share nothing else in common? No shared workshop, no shared mold, no shared craftsman. This was computational pattern analysis, not a peer-reviewed scientific paper, and it does not by itself prove anything. But the pattern it surfaced is worth taking seriously. Within a single dodecahedron, the 12 holes are not simply random or eyeballed sizes. They form a graduated series running from smallest to largest, with the increments between them following a consistent proportional relationship, rather than a flat, evenly spaced difference. That distinction actually matters a great deal. Equal, evenly spaced steps are what you tend to get from a craftsman dividing a range of sizes by eye. A consistent proportional ratio is what you get from someone building a calibrated scale meant to be read precisely, and calibrated scales exist to be read for a specific value, not admired for their appearance. The genuinely strange part is that while the exact numbers drift slightly from object to object, as you would expect from handmade ancient production, the underlying proportional structure keeps reappearing across specimens cast in entirely different provinces, by different workshops, sometimes decades apart, with no possibility of the craftsman involved ever comparing notes directly. If a bronze worker in Roman Britain was simply drilling holes by eye to whatever looked balanced, and a completely different bronze worker on the Danube frontier was doing the same thing independently decades later, with no shared workshop and no shared mold, since lost wax casting destroys the mold every single time, then the resulting proportions across 100+ specimens should look like statistical noise. They do not. They cluster around the same underlying ratio, with only the small variation you would expect from hand finishing, not the far larger variation you would expect from pure improvisation. That kind of consistency, spread across huge distances and long stretches of time with no possible direct coordination between makers, is difficult to explain unless every one of these craftsmen was working from a specification that existed independently of any single one of them, a standard carried by the people who needed the finished objects, and reproduced with enough fidelity that technicians who never met ended up encoding the same underlying mathematics into bronze. This is exactly where the burden of proof becomes serious, because a pattern detected only in old, corroded museum specimens will always carry an obvious objection. Maybe the apparent pattern is simply an artifact of 2 centuries of inconsistent hand measurement, rough antiquarian cleaning, and uneven corrosion at the drilled edges, rather than anything the original Roman makers intended. That objection cannot be settled by finding the same pattern in more damaged objects, because it applies to all of them equally. What the argument needed was one specimen essentially untouched by any of that history, and this is precisely why the Norton Disney find carried so much weight the moment it came out of the ground. It was recovered by community volunteers with no stake whatsoever in confirming any mathematical theory, since the pattern analysis had already been proposed well before this specimen existed in the record. It emerged in close to pristine condition, one of the largest examples ever found in Britain at roughly 8 centimeters tall and 245 grams in weight, completely undamaged, with archaeometallurgical testing later confirming its unusually lead-heavy bronze alloy. And critically, it was recorded using modern 3-dimensional scanning rather than the inconsistent hand measurement of earlier centuries. If the proportional pattern detected across the wider corpus had really been nothing more than an artifact of old damage and sloppy historical record-keeping, this fresh, precisely scanned specimen should have broken that pattern completely. It did not. Its measurements fell in line with the same proportional structure already identified across the broader collection of roughly 130 known examples, genuinely new data that had never been used to build the original hypothesis in the first place, which is exactly the kind of test a real pattern needs to survive. The wider context of the find only strengthens the picture. The Norton Disney dodecahedron came out of a pit that had originally been dug as a sand quarry before later being reused as a rubbish deposit on a site close to a known Roman settlement along the Fosse Way, one of Roman Britain's major roads connecting the southwest of the island to Lincoln, and not far from where a metal detectorist had already recovered a separate Roman religious artifact known locally as the Norton Disney Rider God back in 1989. It is worth adding that the same regions and time period that produced these dodecahedra also occasionally produced a rarer related object, icosahedra, 20-sided solids, following the same basic construction principles. If the dodecahedron were purely a sacred emblem, you might expect its rarer sibling shape to be treated as an even more exclusive religious object. Instead, the icosahedra that survive show the exact same practical signature, precisely graduated holes, careful construction, and expensive material, suggesting not a separate category of holy object, but a variant of the same underlying technology, applied to a different geometric form. None of this proves definitively what these objects measured, whether it was distance to a landmark, an angle for laying out a road, or some other calibration entirely lost to us. What it does suggest, with real force, is that Rome operated on standardization far more rigorously than people often assume when picturing the ancient world. Roman bricks and roof tiles were manufactured to standardized dimensions so that material fired in one kiln could be laid into a structure hundreds of miles away by workers who had never visited the source. Roman milestones marked distance using a mile that meant the same length in northern Britain as it did in southern Gaul, because an empire's logistics simply do not function if units of measurement drift from province to province. And Roman aqueducts represent perhaps the most demanding proof of all: engineering crews cutting toward each other from opposite ends of a hillside, unable to see or communicate with one another directly, expected to meet cleanly with a continuous, precise gradient shallow enough to keep water moving without damaging the channel. None of that is achievable without genuinely shared reference standards producing numbers that mean exactly the same thing to two separate crews. Put that same demand for consistency out on the actively expanding frontier, in unfamiliar and sometimes hostile terrain, executed quickly by technicians who might be reassigned before a project was even finished, and the margin for individual guesswork collapses toward zero. What would have replaced that guesswork is standardization built directly into the instrument itself, which is exactly what a calibrated, proportionally graduated bronze object would represent. If this reading holds, the story of the Roman Dodecahedron stops being a story about an unsolved decorative mystery and becomes something closer to a story about lost technical knowledge. The men who most plausibly carried and used these objects, the Roman land surveyors working at the empire's expanding edge, were never mysterious figures. Their profession is documented. What was never documented, evidently, was the specific working knowledge of exactly how a tool like this was read and used, because that kind of hands-on technical skill was passed directly from technician to technician in the field, rather than written into a manual meant to survive the centuries. Nobody bothers writing down the obvious for people who already know how to do the job in front of them. When the western half of the Roman Empire's administrative machinery eventually broke down, that unwritten, hands-on knowledge did not gradually fade away, so much as it simply fell out of the historical record all at once, leaving behind only the finished bronze objects themselves, fully cataloged in museum collections around Europe and completely misunderstood for nearly 300 years, because every generation that examined them kept reaching for the most familiar domestic explanation available instead of taking the graduated, calibrated holes seriously as a working mechanism. That is the real unsettling part of this story. This was never a hidden mystery locked away in some inaccessible location. These objects have been sitting in plain view in museum display cases, in antiquarian society records, in modern excavation reports for nearly 3 centuries, fully visible and fully measured the entire time. The answer was never missing. Researchers were simply looking at the shape when they should have been looking at the holes, which raises an uncomfortable question worth sitting with. If an object this well documented, this thoroughly measured, sitting behind glass in dozens of museums across Europe, could go completely misunderstood for close to 300 years simply because nobody asked the right question of the right data, what else is currently on display right now, fully cataloged, fully photographed, and still waiting for someone or something to finally read it correctly?